Hey guys, welcome back to a new tutorial. In this tutorial, we are going to talk about how we can do the image processing with the help of OpenCV. We can see this kind of demo, so we can identify that the motion detection of the image. Okay, if something is there in your system, and then if it is not there in your next frame, so it will detect exactly. So okay, so something is missed out on this. And also apart from that, if there is any motion which is detected on your frame, so still it will detect that. Okay, so there is object is identified, new object is identified inside your frame. So this kind of demo we can see it in today's demo, okay, by using Python OpenCV. Let's start writing a program on this. So here I'm going to write a program with the help of Python CV. And this Python CV, which is actually open source computer vision, is a library of programming functions mainly designed for real-time computer vision. And in simple words, I can say it's a library which we can use it for image processing. Let's write a program on this. I'm creating a file, so where we can do the image processing, and where we can capture the data by using your webcam or a laptop inbuilt camera. So currently I'm writing a program so which can do the streaming by using my laptop inbuilt HD cam. And then after that, so I'm actually doing the motion detection by writing a few lines of code. So let's write a program on this. So before doing that, we have to install we have to install OpenCV performing actions for doing image processing on this. So for doing that, as I said, so we can use the command called pip install. Okay, so let me increase the font on this. Go to here and preferences, settings. Settings, then here font size. uh, Described initially, so we have to use the OpenCV for running your program and for processing image processing of your program. So for doing that, there are various ways to do the image processing, and this is the one of the way which we can use it for doing the image processing or video analysis, motion detection with the help of OpenCV. So before doing that, so I would recommend to you install pip install and OpenCV and Python. So with the help of this command, so it will install required dependencies on your computer for the OpenCV. And in case if you face any issues in terms of permissions, and if you are not able to install some of the packages in your C drive, so I would recommend to go for install these packages by using your user account. Okay, this is how you can go ahead and then install the required packages on your computer for performing the image processing. So let's write a program. So after installing that, I'm actually installing, I'm importing OpenCV. Let me save this as like my demo.motion detection.py file. Okay. So yeah. So then after that, after importing, so then next you have to create a video capture object for that. And this video capture object, which is often we have to capture the live stream with your camera. So for that, I'm using like a video, and here I'm using it as the CV2 dot so video. I can say video object, and this is CV2 dot video capture. Okay, so this is how you can declare the object for your video object, and this video capture object, which is actually required for doing the live streaming with the camera with the help of OpenCV. This OpenCV provides a very simple interface to do this, and let's capture a video from the camera. So here I can there is a flexibility. So if I'm running my laptop with inbuilt camera, so I can use a 0. So if I attach any external camera, so I can provide the index for that. like I want to use the secondary camera, I don't want to use the inbuilt camera. So if I want to read the data from the any video file, so I can specify that sample.mp4. So that video name also I can specify that. So for that I'm actually capturing the data with the help of my inbuilt camera. So that's why I have specified my index equal to 0. So after specifying the index value, to capture this video, you need to create a video capture object. It's an argument, either the device index or the name of the video file. We can use anything based on the requirement. So after creating the video object, then now I want to run my video program and in infinity loop. So for doing that, so I'm using infinity loop here, and inside this infinity loop, I'm actually reading the data. So live frame, and here video object dot read. So it actually read the data from the your web camera. So whatever the data, so whatever the live stream is, that the stream, so we can capture, we can read it from the video object. Okay, in your webcam. Then after that, I'm creating one of the variable like is motion detected. So if I use is motion detected, so I'm initializing it as a 0, in the sense there is no motion detected on this. If there is any object is detected, if there is any movement is detected in a video frame, then I will reinitialize it as a 1. Okay. So then after that, as a first grayscale element, so here what I can do, I'm creating a grayscale object here. So I'm using it as OpenCV2.cvg and color. So here I'm using a live frame. Okay, so after using a live frame, and inside this live frame, so I'm actually using the color underscore BGR to grayscale color. So it will indicate that. So first of all, it will create a grayscale image for me in one of the frame, and based on this frame, because as a developer, it is very useful for me. So I can easily identify that okay, what kind of changes I can detect, and we can easily detect in a grayscale image. Okay. So for this grayscale, so again, what I can do is, so I'm actually displaying the Gaussian blur here, CV2, and Gaussian blur and grayscale image. And here I will define that like a 2121, so it will indicate that my image height and width. Okay, so after doing that, okay, now my grayscale image is created. So here what I can do is, so here what we are going to do it, when you start your webcam, first of all it will capture the video, okay, for a minute or a second. So then after that, the next second and next time onwards, so it will automatically compare the your live data with the previous capture data. Okay, so based on that, it will detect that okay, if there is any change between the two videos or two frames, then only it will say that okay, there is a change, there is a delta is detected on this. So for that, what I can do is, so here I'm creating one of the variable like let's say initial static check. So here I'm using it as a none. Okay. So what we can do, if initial static is not a none, okay, if it is a none, okay, and the sense you are running your program first time, and there is no value is recorded on this, there is no motion is detected on this. So in this case, so I can define that okay, initial check is my grayscale element. So that means that if the object is detected, sorry, I mean if you run your program first time, so your entire data will be stored on the initial static check. So next time onwards, if there is any change, if there is something is detected or something, some motion is detected on your video, so then, so it will go to the, it will compare initial static element with the latest live stream data, and it will find out the delta. Okay. So, and if it is detected, so I'm not going to go down below. If I, even if I go down below, so it will not detect any changes. So if it is a first time run, so it will capture the first frame and it will store it on the initial video. Okay, so instead of using it as an initial static element, I could say initial static initial static video frame. Okay, so yeah, this is done. So next, what I can do, so I already captured initial static video on one of the frame. Then after that, I want to find out the difference between the two frames. So for doing that, so again I'm creating the one more frame, that is I'm calling it as difference frame, and open CV2. Okay, and it's a ABC absolute difference and initial, I could say initial static video frame. Okay, then after that I will pass the query. So here what it can do, first of all, when you run this program, so here your initial static video will get set, and then it will continue the loop. Then after that, next when it comes to the below, then what it can do is, so it will actually compare your initial static video with the existing grayscale video. Okay, so then after that it will go down below. Okay, and here, so we can define the threshold value here. So then at what ratio, at what threshold, you can say that okay, there is a change, there is a motion is detected on your video frame. So the threshold value we have to define on this. Here it is a straightforward threshold value. If the pixel value is greater than the threshold value, it is assigned to one value, maybe in a white, as it is assigned to another value, maybe a black. The function is used in a CV2 the threshold. So with the help of this 3D CV2 the threshold value, so we can easily identify that okay, whether the change is detected, and if the change is detected to what ratio. Okay, so for that I'm creating one more frame. Okay, threshold. I'm using it as a threshold frame, and the CV2 dot threshold. Okay, so inside this CV to the threshold value, so we can identify that the first argument should be your source image. Okay, this is my difference image, and then after that, which should be the grayscale image, and the second argument is the threshold value, which is assigned to the classified to the pixel values. So for classifying the pixel values, I can say I'm classifying it as 30 and 255. So if the threshold value is between 30 and 255, and its value is the threshold binary, then I can say that okay, there is a threshold value is defined on this. There are various styles are available for detecting the threshold values. Okay, so here dot threshold thresh binary. Okay, so instead of using the thresh binary, there are various ways are available: thresh binary INV, thresh truncate, thresh 20, thresh 20 INVC. So I will press down some of the inbuilt threshold values here, threshold different styles here. So if you see this, these are the set of different available threshold styles are available. Currently I'm using it as a thresh binary, so for identifying threshold between the two images. Okay, so I'm taking it as next element here. Okay, so then after that, this threshold value, so I got the threshold value. Then after that, the next option is that if I got the element, and if there is any blur, or maybe if there is any clarity issues on my application, or maybe my video capturing issue, what we can do the dilate function. So with the help of this dilate function, we can actually shape a square or circles for the specific entry detected entries. So what I can do, I'm using threshold underscore frame and cv2 dot dilate. Inside this threshold value, a dilate function, so I can pass these are the parameters. Okay, and for the iterations, after two iterations, let's discuss on this dilate, what it can exactly do. This actually the processor follows the some kernel of the specific shape as same as the square or the circle. For example, I have an image, and inside that image there is a changes detected, and then I want to actually detect the change in terms of the square or in terms of the circles. And this kernel has an anchor point which denotes it's the center, and based on this center you can perform the dilation operation on the image using the dilate method. It is also useful in joining the broken parts of an image. okay, with the help of different iterations. These iterations we can increase it as per the requirement, okay. Then after that I have to do the find out the coordinates and this in image processing, so we can call it as a counters. So with the help of this coordinates, we can easily identify that okay, these are the set of coordinates where the change is detected, okay, where the motion is detected. So for doing that, I can find out the coordinate for that. It's a hierarchy, and cv2 dot find counters 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 and threshold frame, using a threshold frame, and then after that cv2 dot tr external value, and cv2 dot chain chain approx none. So it will indicate that these counters are, these are the very useful when you are planning to draw some boundary, some borders or rectangle shapes or circle shapes inside your video frame. So it can be used to draw the any shape provided by you. It's a boundary points, and it's a first argument is the source image. So that's why I'm passing the threshold image, the source image, and the second argument is the counters which you should pass as a Python list. Okay, so these are the set of counters which can be directly calculated with the help of this threshold object. Okay, and based on this index of counters, so we can draw the shapes, circle or rectangle, so based on the requirement. Okay, so so after doing this, so let me draw the counter, let me draw the shapes on this based on the motions detected on your video capture. So if there is any changes detected, counter counter area inside a counter, and the change is this much of pixel, it's like 10,000 pixel, then I don't want to write anything on this. If the change is a very minor change, so I don't want to write anything. So otherwise, even very minor change, even 1 or 2 pixel changes, still it will detect that. So that's why if the change is a bit huge, like a 10,000 pixels, then only so I can detect that okay, there is a change, there is a motion is detected on this. So otherwise, even if I move the mouse from here to here, still it will detect that okay, there is a change on this. So that's why I'm using as 10,000 pixel here. If it is that, so then so whatever the object, whatever the variable we have declared here, so this variable we can declare it as a 1. So it will indicate that okay, there is a motion is detected on this. So now motion is detected on this. Now what I can do, so if motion is detected, then this if condition is not required anyhow, we have declared a variable here. Now I'm drawing the rectangle for identified locations. So I'm drawing the x and y coordinates and width and height. Okay. Then after that CV2, and there is a function called the bounding rect. Okay. And I'm passing a counter list of elements for that. Then after that I'm drawing that CV2 dot and rectangle, and for that there is a live frame is available. So because so far we have worked on the grayscale images and the threshold frame, and apart from that there is a color frame. So if you draw something on the grayscale images, it won't make sense anything, because grayscale images will be shown in the gray format and blur format, and in a gray color. So I'm writing in the live image. Okay, so for that live image is a colored image, so where we can draw the rectangles based on the changes and the motions detected inside your video frame. So passing the x and y coordinates on this, and then after that, so I'm actually using some logic. So with the help of this logic, so it will draw the rectangle based on the given coordinate. So here if you see this, so here the first parameter, I'm passing the image frame, and the second one is x and y coordinates for that, and then after that I'm passing the height and width. Then after that I'm passing the color scale, so which color I want to draw the things. Okay, so here I'm using the yellow color here. So if we remove this, so then it will automatically take the, by default it's a green color. Okay, so based on the color we can define this. So now my program is created. Then after that, so now I can go here and now I can show the changes in the live. Okay, here I'm using it as image show and some title for this. So I'm using it as the title is gray frame, and so for that I'm using it as a gray image. Similarly, I want to showcase difference frame, which will indicate that, okay, difference frame, which will indicate that, okay, so what kind of differences which actually detected in a difference frame. So here difference frame, and similarly I can use one more frame called the threshold frame. Okay, at what ratio, at what threshold actually the changes are, motions are detected inside your image processing. So here I can use threshold frame, and the final one is the live frame, so which is my colored frame. So I can say color frame. So here I can say live frame, so where we can see the actual live data in a color format. So now this about that. So when you run this program, so and if you'll execute, and so I'm running it on the infinity mode, so there is no way to stop this program until so I terminate the program, or maybe I close the windows. So for doing that, so what we can do is, so I'm actually capturing the key here by using OpenCV wait key. So inside this wait key, if I press only one key here, and if the key is my Q, okay, or maybe exit, or maybe ORD. Okay, I'm using it as a Q. So what it can do is, so it will automatically break the entire execution, and after that, just come out of this, and here video. It is my video object. So this video object, I'm actually releasing it from the memory. Then after that, I can destroy all the windows which are open on my OpenCV. Okay, so destroy all windows. Okay. When you run this program, you can see this is my colored view, and this is my difference frame, and this is my threshold frame, and on top of this, so, okay, so I have a grayscale view. Okay, this is my that is the grayscale. Okay, this is the my grayscale view. So if you see this, so if I'm moving my hand around the object, around the camera, so in the difference frame, so if you see this, there is a difference which is actually detected on this change. Okay, this is the initial frame. So if I actually moving the object here, so which actually compare this initial frame with my latest frame. So that's why it will in the right side actually. So I'm drawing the rectangle based on the movements, and this will indicate that this is the threshold value. How much the threshold value is moving around the things. Okay, if the threshold value is between this range, so then only you can detect that, okay, there is a change on this. This is the my grayscale, so which will indicate that, okay, so okay, your objects are moving at the same time. In the difference frame you can identify that, okay, so where is your initial object and where is your latest object. Here is your initial object. If you see this, here is my initial object, and here is my latest object. Okay, so this kind of changes you can find out, and on top of that we can enhance this program by adding the more enhancements on this. For example, so if there is any changes detected on this, so I want to play some sound and I want to play some alarm on this. So this kind of enhancements we can easily do it. So as we prepared a program, so when I press E or a quick command, so it will automatically quit the program. Okay. So this is all about, guys. Thanks for watching. Have a nice day.